So, my dear students, myself, Dr. A. Venkatesan, Assistant Professor, Department of Mathematics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to learn problems in Cauchy integral formula, problems in Laurent series, and problems in residues. The first problem, let C be a positively oriented unit circle and f of z equal to e power 2z and evaluate e power 2z using Cauchy integral formula. So we know that the higher order derivative of Cauchy integral formula. So the higher order derivative of Cauchy integral formula is f power n of z naught equal to n factorial divided by 2 pi I integral over c f of z divided by z minus z naught whole to the power n plus 1 into dz. So which implies integral over c f of z divided by z minus z naught whole power n plus 1 into dz equal to 2 pi I divided by n factorial into f power n of z naught. So let us take equation number 1 and given f of z equal to e power 2z and the point z power 4 equal to 0, which implies that z equal to 0 is a singular point. So now we put n equal to 3 in equation 1. So we get integral over c e power 2z divided by z minus 0 whole power 4 into dz equal to 2 pi I divided by 3 factorial into f triple dash of 0. So we know the value of f of z. So now we find the value of f triple dash of 0. So f of z equal to e power 2z. So f triple dash of z equal to 8 e power 2z. So put z equal to 0. So we get f triple dash of 0 equal to 8. So now we substitute this result in this equation number 2. So therefore we get 2 implies integral over c e power 2z divided by z power 4 into dz equal to 2 pi I divided by 3 factorial into 8, which is equal to 2 pi I divided by 6 into 8 and which is equal to 8 pi I divided by 3. So that is integral over c e power 2z divided by z power 4 into dz value is 8 pi I divided by 3, which is solved by using Cauchy integral formula. Similarly, the second one, the Laurent's expansion of f of z. But you have some three conditions are there. So by given f of z equal to 1 minus 1 divided by z minus 1 into z minus 2. By using the partial fraction only you can simplify, because the denominator is multiple of factor, so we can use the partial fraction. So the z minus 1 divided by z minus 1 into z minus 2 equal to a divided by z minus 1 plus b divided by z minus 2. So which is equal to a into z minus 2 plus b into z minus 1. So LHS equal to minus 1. So minus 1 equal to, so we want find the value of a and b. Put a z equal to 1, we can get a value. Put z equal to 1, we get a equal to 1. Put z equal to 2, we get minus b equal to 1. So b equal to minus 1. So therefore f of z equal to 1 divided by z minus 1 minus 1 divided by z minus 2. So now we are separately split the two factors. So now we are going to consider the first one. The first condition is given mod z strictly less than 1. So which implies you may take mod z by 2 also less than 1 by 2 and which is less than 1, because we have a two factor, one is z minus 1, another one is z minus 2. Z minus 1 is obvious for mod z is less than 1. So the second one only you can be modified. So therefore we may write the f of z equal to 1 divided by z minus 1 f of z equal to 1 divided by z minus 1, and the second one minus 1 divided by z minus 2. So the first one we take minus outside, so therefore minus 1 into 1 minus z whole power minus 1. The second one we need z by 2, so therefore we take minus 2 outside, so therefore minus into minus plus, so 1 by 2 into, we write 1 minus z by 2 whole power minus 1, and which is equal to, we may write minus 1 into 1 plus z plus z square plus etc. plus 1 by 2 into 1 plus z by 2 plus z by 2 the whole square plus etc. So now this can be generalized minus of summation n equal to 0 to infinity z to the power n plus the second one you may write 1 by 2 into summation n equal to 0 to infinity z by 2 whole power n. So similarly we find the second part. The second part is 1 less than mod z less than 2. But two cases, one is 1 by z minus 1, 1 by z minus 2. So the 1 less than mod z, which implies 1 by z, 1 by mod z should less than 1. And the second possibility z minus 2. So mod z less than 2, which implies mod z by 2 is also less than 1. So now we modify the f of z as like 1 divided by z minus 1 minus 1 divided by z minus 2 as 1 by z we need, so therefore 1 by take 1 by z outside, so therefore 1 minus 1 by z whole to the power minus 1 minus the second part z by 2 we need, so we take minus 1 by 2 outside, so therefore we take 1 by 2 into 1 minus z by 2 whole power minus 1. So once again we are expand this expression 1 plus is the 1 1 by z plus 1 by z square etc. So which is we may write 1 by z into summation n equal to 0 to infinity 1 divided by z whole to the power n, and the second one 1 divided by 2 into summation n equal to 0 to infinity z by 2 whole to the power n. So in general you may write summation n equal to 0 to infinity 1 divided by z to the power n plus 1 plus summation n equal to 0 to infinity z power n divided by 2 power n plus 1. So similarly the third case, so the third possibility is 2 less than mod z less than infinity. So here 2 less than mod z, so which implies 2 by mod z should less than 1. So therefore the second factor can be modified in terms of 2 by z. The first one is the 2 is always less than, what's the 2 by z is less than 1, so therefore 1 by z is also less than 1 by 2, and which is also less than 1. So therefore we modify the f of z for the given function is 1 divided by z into 1 minus 1 by z minus 1 by z into 1 minus 2 by z. So once again we apply the binomial expansion, we can get the solution. So next problem, to find the residues of the function. So the first one, using Cauchy residues theorem to find the value of integral over 5z divided by z into z minus 1. So that is f of z equal to 5z minus 2 divided by z into z minus 1. So now first we find the singularity, so isolated singular point. So z into z minus 1 equal to 0, which implies z equal to 0 and z equal to 1. There are two possibilities. So the first thing should to find the residue at z equal to 0, and the second one to find residue at z equal to 1. So now to find residue at z equal to 0. So residue at z equal to 0 of f of z. So which is equal to 5z minus 2 divided by z into z minus 1. So now z equal to 0 came from 1 by z. So we keep 5z minus 2 divided by z as it is, and we modify 1 z minus 1 as an expression. So which is equal to minus of 1 minus z whole power minus 1, and which is equal to 5z minus 2 into minus 1 by z of 1 plus z plus z square plus etc. So now we multiply 5z minus 2 inside this one. So therefore we can get minus 5 minus 5z minus 5z square minus etc. The second minus 2 we put outside, so minus into minus plus, so 2 by z plus 2 plus 2 z plus 2z square etc. So now we find the residue at z equal to 0. The residue at z equal to 0 means the linear coefficient of 1 by z. So that is 1 divided by the coefficient of 1 divided by z. So here the coefficient of 1 by z is 2. So therefore residue at z equal to 0 is 2. Therefore the residue at z equal to 0 of f of z is 2, that is b1 we take B1 equal to 2. So similarly, to find the residue at the point Z equal to 1. So what we find? Residue at Z equal to 1 of f of Z. So Z equal to 1 is from Z minus 1. So therefore Z minus 1 we keep as it is. So we modify the Z value. So therefore I can write the 5Z minus 1 divided by Z into Z minus 1 is 5 into Z minus 1 divided plus 3 divided by Z into Z minus 1, and which is equal to 5 by Z plus 3 divided by Z into Z minus 1. So what is we need? The linear coefficient of 1 by Z minus 1. So that means the coefficient of 1 by Z minus 1 we need. So now we express the second term. So which is the first one we keep as it is. The second one it can be modified. So 3 divided by Z can be modified as 1 plus Z minus 1, and Z minus 1 we keep as it is, and which is equal to 5 by Z plus 3 divided by Z minus 1 into 1 plus of Z minus 1 whole power minus 1. So which is equal to 5 by 2 plus 3 divided by Z minus 1 into, we express this one, 1 minus Z minus plus Z square, etc. So 1 minus Z minus 1 plus Z minus 1 the whole square minus etc. So now we multiply the Z 1 by Z minus 1 inside the value. So we can get the residue at the point at Z equal to 1 of f of Z is the coefficient of 1 divided by Z minus 1. So which is equal to 3. So we multiply inside this one, we can get only the coefficient of 1 by Z minus 1 is 3. So which is we take, and we take this one is B2. So what is Cauchy residues theorem? Integral over C f of Z into dz equal to 2 pi I into sum of the residues. So sum of the residues here B1 plus B2. So which is equal to 2 pi I into, so B1 is already the first one we find, which is equal 2, and B2 is 3. So therefore 2 plus 3, which is equal to 10 pi I.